Before we start the challenge, I just want you to be aware of the pricing for the transit gateway and the resolvers. For the transit gateway, you're going to pay per attachment and per gigabyte of data processed. You don't have to worry about gigabytes of data processed because we're not going to send gigabytes of data anyway, but be aware of the attachments. We're going to have 4 transit gateways and each one of them will have attachments, so just watch out for that cost. For the resolver, we're going to have 4 endpoints, and each one of the endpoints, they need at least 2 IP addresses. This is the cost for a single IP address, which is 0.125. So if you have 2 IP addresses, that's going to be around 25 cents per hour per endpoint. And because you're going to have 4 of them, that's at least $1 every hour. Okay, so I think we're ready to start. So you can head over to github.com, the Dojo series Global Transit Network. And I'm going to skip a lot of these because I've already talked about it. Let's start building the solution. The first step is going to be to split a global CIDR range into smaller regional ones. So the requirement is that we're going to have a global CIDR range, which is going to be 10.112.0.0/12, which would give us around 1 million IP addresses. And then we know that each country should get the same number of IP address, which means we're going to have to split this /12 equally. In Canada, we're going to have a environment called global services, which is where the log collector would be deployed in this case. And that VPC should have up to 510 IP addresses available. Now for UK, Brazil, and Australia, that they're going to host a production environment, UK should have up to 8,190 IPs, Brazil should have up to 4,094, and Australia 16,382. So what we're going to do now is to use the visual subnet calculator to calculate all of these addresses. To split the global CIDR range into 4 equal ranges, let's start by typing in the address for the global range. So that's going to be 10.112.0.0/12, and then click on update. And you see that we have the address here, and that's how many IP addresses you would have. If you want to split, you basically just click the divide button. And now you see that we have a /12, which turned into 2 ranges of /13. But we need 4, so let's split 2 times more. And here you have it. So the /12 became 4 addresses of /14. And here we can see that we're going to have the same number of IP addresses. The first IP address, it's going to be for Canada. And this is not the global services environment. That's the entire country, which means that if you have global services plus other environments in Canada, you would have to use this range and split into smaller ranges. And that's what we're going to do later for the global range. But the first one is going to be for Canada. The second one is going to be for the UK. The third one, Brazil, and the fourth one, Australia. If we go back to the challenge, we'll see that the global services, we actually need 510 IPs, and then UK 8,000, etc. Here you see that we have way more than we actually need. And like I said, this is for the entire country. If we want only 510, we're going to have to split this /14 into much smaller range. So let's start clicking divide until we see 510 IP addresses. There it is. So 510 addresses, that'll be a /23 address. Now you'll notice that there are 2 /23 addresses, but we can actually have as many /23 as we want if we start clicking divide in each one of these ranges here. But we only need 1 of them, and which one you're going to pick, it doesn't really matter. But just to make things simple for us, I'm just going to get the first one. This is going to be the address for the VPC, which is going to be called Global Services, and it's going to be deployed in Canada. So write down this IP address. Now let's calculate the address for the VPC in the UK. If you want to go back to the /14, so you see that all this /14 here, which is covering all the smaller ranges, this belongs to Canada in our case. So click on the /14, And then we're going to go back to where we were before. And let's work on this 116 address, which is UK address. For the UK, we need 8,190. So let's try to find 8,190 here. There it is. And I'm just going to take the first address that I see here. So for the UK, our VPC is going to have the address 10.116.0.0/19. For Brazil, it's going to be a little more than 4,000. So let's split the third range until we get 4,094. So write it right here. And so the address for Brazil, it's going to be, let me go back. It's going to be at 10.120.0.0/20. And finally, Australia is just over 16,000. So right here, it's going to be 10.124.0.0/18. Now that we have all the VPC addresses, let's calculate the subnet addresses. The requirements for the subnet addresses are, for the global services, each one of the subnets should have up to 126 IPs. For the UK, 4,094, Brazil, 62. In Australia, we're going to have one subnet with 8,190 and the other subnet, 4,094. Let's start with global services. I'm just going to bring back the IP address that we had here, the range, which was 510. And that was the range. So this is the address of our VPC. And if you want to find out the subnet address, we're just going to split this address here. The requirement is that we need 2 subnets of up to 126 addresses. So this means that one subnet is going to have this address, and the other subnet is going to have this address here. So write those one down. That we're gonna be using them when we launch the VPCs. Now for the UK, we need 4,094. So let's go back to our address here. And if we split the /19 into 2 /20s, that's gonna give us 4,094. And here we have the address of one subnet and the address of the other subnet. For Brazil, we only need 62 IP addresses, so that's going to be a small one. Let's go back to our address, which is this, and let's split this into /26. So /26 would give us 62 IP addresses, and this is going to be the address for each one of the subnets. This is the address then for Brazil, and finally, let's do the same for Australia. Go back to our 16,000 IP addresses. This is the VPC address, and we need 8,190 for the first subnet. This is gonna be the address for the first subnet, but the second subnet, we actually need 4,000 IP addresses, not 8,000. And if you're wondering why we would have 2 different ranges for subnets in the same VPC, imagine that you're deploying, let's say, an application and database in the same VPC. Ideally, you would separate the application and the database into separate subnets. Now, it might be the case that your application needs more IP addresses than your databases. And so if that's the case, you don't have to allocate the same number of IP address for the subnet where the database is going to be if the database doesn't need to consume as many IP addresses as your application does. So that would be one of the reasons why you would have different ranges for subnets in the same VPC. Coming back here now, so the first one is going to be the address for the first subnet. And what I need to do now is split the second one, because if I split this, then I'm not going to have 8,000 anymore, so I can't touch that. So the first subnet is going to be a /19, and the second one, so this is the second address, second /19. So I'm going to split that one, and I'm going to have 2 /20, but doesn't matter. I just need one of them. And what I'm going to do is I'm going to take 10.124.32/20, which would give me 4,094. So for Australia, just to recap, we would have the first subnet, which is a /19, and the second subnet is a /20. I hope you wrote all of these addresses down, because in the next video, we're going to launch all of these VPCs.